Did you end it?
No.
I want to be a princess.
Was that the ding sound?
Yeah.
What?
That's
Megan has-
disappointing. I thought Luke was joining us. Turns out
Because
all you've
you
done is
turn
added
the fancy.
a tiara.
Oh, I didn't realize that happened. I just wanted to be a princess.
It's probably random.
That's all it does. It
Because I
doesn't.
was a
It doesn't
chipmunk.
turn you into an actual princess.
I always have
My hat is a bit off.
It does not turn you into an actual
Yeah, we
princess.
did.
Okay. Quotient rule. Quotient rules. 3 minutes. This is quick and easy, and with just polynomials, it seems not worth it. You guys are whispering. I don't like that.
Counting motions.
Who's the day? Not everything. You're coming into my screen.
Yeah, it's a little over the top, RJ.
Jeez. Calm thyself.
Calm thyself down.
Have another cup of coffee.
So,
What's that? We could actually use the example. It's in the examples.
oh, never. Are we starting?
Well, this is where we're starting, so
Look it up.
if we're taking notes, this would be a good way to set up.
I didn't take
I am taking notes. I have paper out.
Wow.
I always take notes.
from the lesson.
If this means I don't have to watch the lesson, I am down.
Down with it? Yeah.
Like, I can't watch those lessons. I don't learn anything from them.
Is that right?
I'm just
Okay.
reading the slides nowadays.
Yeah, actually, I
I
think
read the
reading the
slides, but it
slides
takes a
can.
long time.
Oh, really?
So
Okay.
I,
All right.
And I don't feel like I learned anything.
Okay.
So,
Well, good to know. So here we are. Quotient rule. RJ, I'm hoping you remember the quotient rule. What's quotient rule? So I have a function that is basically a function over top of a function. This is a quotient. And there's a rule. And as you go through like the little preamble, we'll go over the rule. And it's a song. It's a song. It's a beautiful song. So as RJ has learned from the preamble, the song goes as follows. There's a top function, P, and a bottom function, Q. In this case, P is 3x minus 4, and Q is x squared plus 5.
This is a really nice song.
It is. It goes like this. Bottom times the derivative of the top minus top times the derivative of the bottom. And then my favorite part of the whole song is all over
Or B.
the bottom
Square.
squared. Yeah, that's right.
Oh, actually, it's cool.
Yeah. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared.
What do you have?
And really the preamble just kind of takes you through that.
I don't know what you have. I'm good with this.
Oh man. Okay.
So let's
So-
get something totally different.
Now for something completely different.
Oh, I think it's still fish.
Okay. So in this quotient, what is P? In this function.
3x minus 4.
3x minus 4. Yeah. And so P prime is
3.
3, and Q is
X squared plus 5.
x squared plus 5. So Q prime is
2.
2x. Okay. Good. Now we just have to do this to these. Okay. And take it away.
Sorry, x squared plus 5
Bottom
times 3
times the derivative of the top minus
3x minus 4
top
times 2x
times the derivative of the bottom
times
all over
x squared plus 5 squared.
the bottom squared. Yeah, that's right. And it looks like we can do some expansion and simplification here. Minus 6x squared plus 8x. So it's like negative 3. Oh, I guess I better put the bottom squared under that, or it's like a totally different function. Okay, and then I can simplify that in this last little bitty bit of space that I've got. 11x squared. No, that's not 11x squared. I'm not got that right. Negative 3x squared plus 8x plus 15. And over x squared plus 5 all squared. Okay, so that's quotient rule. Did I make a mistake? Just let me know if I made a mistake. Is it? Oh,
I just can't see out.
okay. Not tall enough. So it's not clear when you're looking.
Like, it is, but it's hard to see.
Okay, so I need to make that bigger, is what you're telling me.
Well,
Bigger and
I can tell that it
less
says
scratchy.
negative 3x squared plus 8x plus 15.
15. Yeah, that's
But
perfectly
then
clear.
the bottom is
The
kind of
bottom's crunched up.
a wee bit squished.
Just in case the lesson is completely wrong.
Well, I don't know. I'm hoping I didn't get that wrong. I think it's all good though.
It's really nice for your paused one.
Ready for example 2 yet?
Argus on. Okay, Argus is a copy of mine, so.
Okay, here we go. If you're joining us on the internet, just hit pause.
Not for us. We're watching it live.
Oh, you
I meant
can go. It'll be on YouTube later.
Oh my god, we're gonna be famous.
Actually, you won't be on YouTube.
Our voices will be.
Yes, it's true. So if there's like some evil stalker out there
That knows me.
that does something dangerous on YouTube with people that he/she sees on YouTube. Okay. Y equals 3 over, oh, that's 3x over x plus 4. Find the points on that graph where the slope (12/25). Okay, so we have to find the points on the graph of y equals 3x over x plus 4 that have a slope of 12/25, or at least where the tangent has a slope of 12/25. Problem. Hey, what are we going to do? It's calculus.
Quotient rule.
Hey, let's use the quotient rule. What a great idea.
Wow.
Sing along with me.
Or not.
So let's find the slope first. Who's going to find the slope for me? Quotient rule? It's a song.
Oh, that's what you're asking.
Yeah.
Okay, Gotcha. Oh geez. Q, so that's x plus 4.
Bottom,
Okay. Times
the derivative of the top,
3
minus
minus 3x
top
plus
times the derivative of the bottom, which is just 1. All of the bottom squared. Pretty good. Okay. Now, we are trying to find the value of x that makes the derivative equal to 12 over 25. So what we really have to do is we have to solve this for x. Look at what's happening, everybody.
Whoa!
This is going to get easier before it gets harder.
That's
That's nice, eh? So we got 3x minus 3x plus 12. So we can just continue to simplify this to, I'm going to erase this question. No, I'm going to put a wavy line under it, thus separating it.
It's very beautiful.
Thank you very much. Okay, so this actually simplifies to 12 over
X
plus 4 squared. And that is going to be equal to 12 25ths at the point of interest. Okay.
So the new cross multiply.
Yes, you can. You can also cross divide. So in other words, I could like divide out these 12s first. Okay. You get there.
It's easier.
Yeah. So basically, really, this means x plus 4 squared is equal to 25.
Okay.
Ta-da. Now we're going to go over here, up, back here. Sure that this is all.
It's really nice continuity.
Lots of continuity there. Okay. X plus 4 squared equals 25. So x plus 4 equals?
5.
You are so close, but you're wrong.
Oh, sorry.
5.
Negative. What?
Yeah, plus or minus.
Oh.
Yep. So x is equal to 4 plus or minus 5. So x could be equal to 9, or x could be equal to
1.
Negative 1. Yep. 4 plus 5 or 4 minus 5?
Well, we have to do like 1 plus 4 to get 5. Oh, sorry, gotcha.
Okay, right.
I don't know what I
It
was
makes
thinking.
slight amount of sense.
Yeah.
It's good. Okay. So now we want to find the y coordinate when x is 9. So when x equals 9, y is equal to 3 times 9 over 9 plus 4, so it's 27/13. And when x is equal to -1, over, and oh. So our first point was actually at 9 and 27/13. Our second point is actually at
-1, -1.
-1, -1. guess if I was really doing my job, I would have probably prepared that function in advance with the tangents. Then if I make a mistake here, the board shows up wrong. Okay. Did you want to do one more? Yeah, no? Do the challenge problem?
I'm okay with that.
You're okay with that? Okay, so the challenge problem is actually in the lesson. So I will show you, actually, I'll pose the question. I'll show you what the quotient is. Sorry, what the derivative is. And then you have to tell me how that proves. So the question is, prove tangents to 5x plus 2 over x plus 2. So you have to prove that tangents to that all have a positive slope. Okay. Offhand, can you tell me what I should do to start to prove that?
The quotient
Hey,
rule.
let's take the derivative, use the quotient rule. Yeah. So let's just pretend that I've done all this work. And I find out that f prime of x is equal to 8 over x plus 2 squared. So I've done the quotient rule. I've done bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. And this is the derivative. And I want to prove that the slopes are all positive. How could I prove the slopes are always positive? I'm looking at that. How does that prove the slopes are always positive?
No matter what number you put into x or y.
And why is that? You're right,
It's squared.
because you're squaring it, and this is positive on top. Ta-da! That's right. That's the question, challenge question. Okay, so all you really had to do was take the derivative and then
Use common sense.
use common sense. That's all math really is. Good. Okay. That's that. Quotient rule.
Right.
Okay. I'll tell you what. Don't think you need to do all the exercises. So you guys are telling me it's taking too long to do like all the exercises. So I'm going to look at like a lot of the interactive practice exercises, cover most of what I want you to do from a technical standpoint, and then I'll assign like a couple of questions
Can you
in
see
the
our
exercises.
interactive test quiz?
Why are you asking that?
No, I'm just curious.
No, I can't.
Okay. It said, so there was one thing that said like have your teacher grade your interactive marks or something, like your teacher will be able to grade your marks or something.
Oh,
Or
really?
your answers.
Okay.
And I was like,
Hmm.
that's
Well,
what-
you can if you come to the teacher and say,
Yeah.
could you grade my thing? Yeah. All right. So that's the quotient rule. Is that easy?
Yeah.
Yeah. Yeah, in fact, all calculus is pretty much this, like, take the derivative, that's the slope, and then calculating tangents might be the trickiest thing. And that, by the way, that's the last of the rules. And actually, since you know the derivatives of trig functions, there's some proofs, but we just have to go over those. So that's that. All right.
Yeah.